Hey guys, welcome to question FM314 of the Further Maths Fortify study guide. This question reads, a 10-meter ladder is leaning up against a wall and it slips 1 meter to the right as shown below. And then we're given this diagram here. The question then asks, the vertical distance D in meters is closest to what? So in order to figure out this difference in height, I'll create a little setup. To figure out what that difference in height would be, we're going to need the original height and we're going to subtract the height after it slips from that. So we're going to figure out two things. So we're going to start with the original. Now, the way that we would find the original, if we look at the original triangle that we would have had as a setup, originally the ladder was 6 meters away from the wall at the base, and we've also been told that this is a 10-meter ladder. So where the ladder would be leaning is going to have a value of 10 meters there. Now this unknown height over here, the original height, that's what we're looking for. We can call it x for now. So we've got two known sides of a right angle triangle and one unknown. This unknown isn't the hypotenuse, so the formula that we would use would be this a squared equals c squared minus b squared, or some equivalent to that. We like to convert this to a equals the square root of c squared minus b squared, since we are looking to go straight to whatever this length is over here. Substituting our known values, well, a is this side that we're solving for, so we'll insert x there, or substitute x there. And then c is always our hypotenuse, so we're going to take that as 10 squared minus, and b is going to be our other side length, so 6 squared. So plugging the square root of 10 squared minus 6 squared into a calculator should drop out a value of 8. And of course that means that the original height was 8 meters high. We're now going to look at the height after the ladder slipped. So setting up this triangle, once again we have a 10-meter ladder. This time the ladder is 7 meters away from the base, so slid that extra 1 meter along, and we're going to say that the slipped height is called y. So once again, using the same formula as before, we're using a equals the square root of c squared minus b squared, inserting our known values. C once again is always the hypotenuse, so 10 squared minus 7 squared, and plugging that into your calculator, you should get an answer of root 51 meters. So to find out this value for D is going to be equal to our original height, 8 meters, minus our slipped height of root 51 meters, which if you plug that into a calculator, you should get an answer that when rounded to 2 decimal places, 0.86 meters, which looks just like option B. And there you have it. If you guys have any questions for us about this question, please drop them in the comments below. Otherwise, I will see you in the next video.